Hi, I'm David Dodge. Welcome to Green Energy Futures. An Alberta geothermal company believes they've cracked the geothermal nut, making affordable heat and power geothermal plants available anywhere. EAVOR, a Calgary, Alberta-based company, has pioneered a closed-loop geothermal system that borrows technology from the oil and gas industry to build full-scale geothermal heat and power plants. The closed-loop system involves drilling 4 to 7 kilometers deep into the rock, and then another 4 kilometers horizontally to harvest consistently high temperatures. The result is a power plant and enough thermal energy to heat entire towns.
My name is Janine Vanny. I work for EVAOR Technologies. We are an advanced geothermal technology company. We use the heat beneath your feet to provide utility scale heat and power using oil and gas technology. Our operations are completely carbon free. We use very little land and water, and we have the ability to act as an earth battery.
EVOR's proprietary approach uses a closed loop system that can work anywhere.
We build deep underground pipelines that are completely closed and sealed off from the underground. And the reason that's important is instead of looking for a needle in a haystack, which is my analogy for looking for an aquifer for a hydrothermal reservoir, we're looking for the haystack. Heat is everywhere beneath your feet. You need a way to get it out of the ground.
EVOR drills down deep into the rock and installs what they call their Everloop system, similar to shallow geo-exchange systems you might install on your farm.
Every kilometer down you go, the earth gets 30 degrees C hotter.
EVOR is targeting 150 to 200 degrees Celsius temperatures. Here's how they do it.
So you drill down vertically, or you dig down vertically about 4 to 7 kilometers, depending where you're drilling. You drill simultaneously 2 wells side by side, and you drill down to about 4 kilometers, and then you turn horizontally and you drill some more, another 3 or 4 kilometers. And at the end of those wells, you connect them using a magnetic ranging technology, which is an anti-collision technology from the oil and gas sector that we use it to collide wells and close a loop.
Fluid in the closed loop returns to the surface thanks to a thermal siphon.
The fluid goes into the organic Rankine cycle, which is the power plant, and then that hot water hits a working fluid that's inside the organic Rankine cycle unit, and it has a lower boiling point than water. That's where you're thinking steam. So it flashes, and when it flashes, it turns a turbine. So for the listeners, think of a wind turbine. When it turns, it creates electricity. It's the same thing inside of one of these little binary cycle power plants. Once that flash happens, the turbine spins and electricity is created. So that's how you harness Earth's heat to create electricity.
It's innovative, but it's an elegantly simple system that works very well. But before EVOR could sell large projects to customers, they did a pilot project to prove their technology.
The pilot is near Rocky Mountain House in central Alberta, so oil and gas country, farm country. But when we did it all, it was very much like Eureka. But of course it works. It's off-the-shelf technology that's used in other settings. We're just using it to progress geothermal. So what we learned from that was a couple things. One is we can predict our thermal output prior to drilling. This is much like if you're going to design a solar plant, you know how many megawatts you're going to get out of it. We can do that. Conventional geothermal can't do that. That's what makes it different. And we've been operating within 2% of the predicted thermal output for 5 years.
The pilot was so successful, they soon attracted a major customer in Germany and is now building a full-scale heat and power geothermal project there.
The project is located near a town called Geretsried, which is located in Bavaria, which is in southern Germany. And the project itself is an 8 megawatt electric project, 64 megawatts thermal. It is funded in part by the EU Innovation Fund. So we received a 90 million euro grant from the EU Commission to get that project up and going.
This involves 90 kilometers of drilling and more than 300 kilometers of pipe in the loops. It'll produce enough electricity for 8,000 homes and enough heat for 120,000 homes of the region. EVOR CEO John Redfern believes they can do this for 7 cents per kilowatt hour for electricity and very competitively for heat. This is a revolution for geothermal, which can provide both baseload and dispatchable electricity and affordable emissions-free heat. It could be the missing link that helps grids incorporate large amounts of solar and wind power. And it's a godsend for European markets that are desperately trying to get off of natural gas and coal.
Geothermal's having a bit of a renaissance right now. And so there's a lot of district heating networks that are coal-fired fed currently in Europe. And they're shutting down all the coal because of the climate strategy and because of the energy security crisis. You know, they're in dire need of heat, and they see geothermal as a key part of the solution. So there's a very strong push, or maybe that's a pull, for geothermal energy, in particular next generation geothermal energy like the Everloop, because we can put it where it's required. We have follow-on projects in Germany that are other heat projects. We have another project in design phase in the Netherlands. And we have a portfolio here in North America that we're working through. There's about a handful of projects that are in the feasibility stage.
EVOR's founders believe the closed-loop system is a game-changer for geothermal, which can now be deployed anywhere and, more importantly, can provide baseload heat and power, the missing link in the clean energy revolution. EVOR is so bullish on their approach, they're already planning to license their technology for faster deployment around the world. If you like stories about building a sustainable future, subscribe today. We have almost 400 stories on YouTube. Check out our blog at GreenEnergyFutures.ca. For Green Energy Futures, I'm David Dodge.